Peptic ulcers are painful sores in the lining of our stomach or the first part of the small intestine. By the 1970s, the medical community had widely accepted the theory that excess stomach acid was a root cause of peptic ulcer disease. This famous no acid, no ulcer dogma was based on decades of rigorous scientific study and supported by sound experimental evidence that acid-reducing drugs cured the painful symptoms of ulcers. In this video, we'll see how the subsequent discovery of a gastric bacterium, Helicobacter pylori, or H. pylori for short, transformed our understanding of peptic ulcer disease. The two Australian physicians who elucidated H. pylori's role in ulcer disease, Barry Marshall and Robin Warren, were awarded the 2005 Nobel Prize in Medicine for their groundbreaking discovery. This video is part of the problem-solving video series. Problem-solving skills in combination with an understanding of the natural and human-made world are critical to the design and optimization of systems and processes. Hi, my name is Adrian Lee and I'm an Emeritus Professor of Medical Microbiology at the University of New South Wales in Sydney, Australia. I've worked on spiral-shaped bacteria in the intestine since 1968 and so worked in parallel with Marshall and Warren over the course of their discovery. One of the greatest moments of my life was when they invited me and my wife to the Nobel Prize award ceremony in Stockholm, Sweden. Thus, I know their story very well and consider it to be a wonderful summary of science in action. Before watching this video, you should be familiar with the scientific method and its central role in the investigation of scientific phenomena. By the end of this video, you will be able to 1. Describe the general steps of the scientific method, 2. Recognise the complex and multifaceted nature of the scientific process, and 3. Explain how the discovery of H. pylori and its connection to peptic ulcer disease exemplifies key aspects of the scientific process. Before going into Warren Marshall's story, I first have a question for you. What do you think are some of the steps involved in the process of scientific investigation? Some of you might have said conduct experiments, make observations, analyse data, disseminate results, or something similar. These are all key elements of the scientific method. The scientific method provides us with an objective and systematic way to focus our inquiry and organise our curiosity. As shown here, the scientific method is often presented linearly, but really the scientific method is highly iterative and non-linear. Most scientists do not follow a rigid checklist. There isn't one standard way to do science. Science is a dynamic process, not a fixed methodology. Let's return to Marshall and Warren and the events that led to their Nobel Prize-winning discovery. See if you can identify the various elements of the scientific method. Our story begins with Robin Warren, a histopathologist at the Royal Perth Hospital in Western Australia. In 1979, Warren noticed a thin dark line in specimens from his gastric biopsy patients. He switched the microscope to a higher magnification and observed what looked like spiral-shaped bacteria. He noticed the bacteria almost always associated with evidence of gastritis, or inflammation of the stomach. Warren was convinced that the bacteria were important, but at the time doctors believed that no bacteria could survive in the acid stomach, and thus showed little interest in his work. 2 years later, Barry Marshall, then a young clinical trainee in the same hospital, joined Warren in his study of gastric bacteria. Warren convinced Marshall that the spiral bacteria were significant and not just contamination from the laboratory. To further study the bacteria, they would first need to grow up cultures in the lab. This proved to be frustratingly difficult. Marshall tried culturing spiral bacteria from 30 different patients. The result was always the same, blank Petri dishes. Then, in April 1982, Warren and Marshall left for the Easter holiday. And when they returned from the 5-day break, they were surprised to find thriving bacterial growth. The problem hadn't been the culture process. The bacteria were simply slow growers. And after more than a year, Marshall and Warren finally had their bacterium. Microbiologists at the Royal Perth Hospital started identification tests and found the bacterium to be of a completely new genus. It was eventually named Helicobacter pylori, or H. pylori. As they were trying to grow the bacterium in the lab, Marshall and Warren were also trying to determine the medical role of their bacterium. They examined gastric samples from 100 patients where, to their surprise, H. pylori were found in more than half the specimens. The bacterium was almost always present in patients with gastritis and peptic ulcers. So Warren and Marshall began to suspect that gastric diseases were in fact caused by H. pylori and eagerly presented their findings to the medical community. Much to their disappointment, their bacterial theory was widely rejected and ridiculed. It was an uphill battle trying to publish their results in medical journals. Instead of backing down, Marshall and Warren sought other opportunities to spread the word. They presented their results at the European Campylobacter meeting in Brussels in September 1983. I was in the audience that day and can still recall the excitement of hearing about this new bacterium. At around the same time, an English microbiologist, Martin Skiro, successfully cultured H. pylori from biopsy specimens in his own laboratory. He convinced the influential medical journal, The Lancet, to publish Warren and Marshall's definitive paper in 1984. Again, their radical hypothesis was harshly condemned. Some criticised their lack of experimental controls, others dismissed their idea as offensive. To move forward, Warren and Marshall would need more experimental proof that H. pylori caused gastritis and peptic ulcer disease. The usual way to prove a bacterium causes a particular disease is to use an animal model. In other words, find an animal that is also susceptible to the disease. And early on, animal models for H. pylori were hard to find. Frustrated and not being taken seriously, and hindered by this lack of an animal model, Barry Marshall came up with a dramatic way to prove this point. He drank a culture of H. pylori. Marshall became ill with nausea and vomiting within a week. Endoscopy confirmed the presence of gastritis and H. pylori, and more importantly, the symptoms disappeared after antibiotic treatment. Marshall now had some evidence linking H. pylori infection of a normal stomach to gastric inflammation. Still, this did little to convince the skeptics. In science, a large sample size is important to achieve statistically significant results. This experiment with just one subject was clearly not good science. However, it certainly captured the attention of the media, and the word of the guinea pig doctor who discovered a new cure for ulcers started to spread. Marshall and Warren's finding gained significant support among members of the microbiology community, who were immune to the no acid, no ulcer dogma of the medical profession. Several microbiologists, including Martin Skiro and myself, became intrigued by H. pylori and set out to understand it better. Well after Marshall volunteered himself as a test subject, I and a colleague at MIT, Jim Fox, successfully developed a mouse model of infection using what we call the Sydney strain of H. pylori. This and other animal models provided a starting point for further studies on H. pylori and its role in peptic ulcer disease. In the early 1990s, evidence built up in support of Marshall and Warren's hypothesis. Clinical trials showed that antibiotics not only cured the symptoms of ulcers, but also prevented their recurrence. In contrast, acid-reducers medication alleviated ulcer symptoms, but not their recurrence. In 1994, 15 years after Warren's initial observation, a panel from the US National Institutes of Health finally published a statement stating that the key to the treatment of peptic ulcers was detection and eradication of H. pylori. It had taken more than a decade of exhaustive research by Warren, Marshall and many others for the bacterial theory of ulcers to gain official acceptance. The impact of Marshall and Warren's work was profound. Peptic ulcer disease is no longer a chronic, debilitating medical condition. We now know that many ulcers are caused by bacteria and can be cured permanently with antibiotics at a fraction of the cost of earlier treatment methods. Can you identify steps of the scientific method that Marshall and Warren used in their discovery? You might have noted Warren's initial observation of H. pylori in gastric biopsy samples, or his questioning of H. pylori's role in gastritis. Marshall and Warren hypothesised a bacterial cause of gastric disease, and subsequent experiments demonstrated the effectiveness of antibiotics in the treatment of peptic ulcers. Finally, they disseminated their findings amongst the medical and research community. The Helicobacter story illustrates how good science is at the heart of every important scientific discovery. However, science is only one part of the story, and as we've seen, even good data can be met with rejection. So what personal characteristics allowed Marshall and Warren to ultimately succeed despite overwhelming skepticism and negativity? There are a few characteristics that I believe were crucial to Marshall and Warren's success. Curiosity. Fundamental to the process of discovery is the insight of the individual investigator. This story is a result of Robin Warren's keen observation of a few spiral bacteria and his desire to determine their origins. Luck. From Warren and Marshall's initial meeting to the long Easter weekend away from the lab, there is no question that serendipity played a significant role in their scientific journey. Tenacity. Warren and Marshall's persistence was exemplified by their dogged determination to tell others about H. pylori even in the face of constant criticism, with Marshall even volunteering himself as a guinea pig. By turning to microbiologists and other scientists to address the questions surrounding H. pylori, they eventually gained acceptance in the medical community. In this video, you've heard the fascinating story of Robin Warren and Barry Marshall and how it took them more than a decade of experimentation and the right mix of curiosity, luck and persistence to overturn the deeply entrenched no acid, no ulcer dogma of the medical establishment. As their guest at the 2005 Nobel Prize Award ceremony in Stockholm, Sweden, I had the privilege of seeing our two heroes receive the ultimate reward in scientific research, the 2005 Nobel Prize in Medicine for their groundbreaking work on H. pylori. So often science is taught as irrefutable truth, but this story reminds us that scientific truth can and does change in the face of new evidence. Moving forward, I hope that you will bear in mind the various elements responsible for Marshall and Warren's success and apply them to your own learning.